Like morphology and anatomy, the chemical composition of the seed is largely dependent on two things. First is the genetic makeup of the plant producing the seed, and second is the environment. In this part of Module 4, we will talk about the effects of genetics and the environment on the chemical composition of the seed. Under environmental factors, we will specifically look at the effects of soil fertility and moisture, temperature, and cultural practices on seed chemistry. The natural variation that can be observed in the chemical composition of seeds of different species and of seed parts is basically determined by the genetics of the plant that produces the seed. In this table, for example, you can see variations in the amount of proteins and lipids across different species of plants. Protein content in particular can range from a low 3.2% in acorn to a high 37.9% in soybeans. The same is true for lipids. Lipid content in the seeds of the species listed in this table ranges from 0.2% in mung bean to 47.7% in peanuts. These differences in protein and lipid contents are natural variations that can be attributed to the genetic makeup of each species. Even within a seed, the distribution of chemical components can vary, and again, this natural variation is due to the genetic makeup of the plant. This slide shows you the starch, sugar, oil, protein, and ash content in the different parts of a corn seed. Corn is a monocot, and monocots are known to contain higher proportions of carbohydrates. In this slide, we can see that the total carbohydrates in the form of starch and sugars make up the largest proportion of the seed reserves. This is followed by the proteins and then by the lipids. Carbohydrates are distributed in the endosperm, embryo, as well as the pericarp and testa, and you can see that the endosperm has the highest starch content. The variations in the proportion and distribution of different chemical components into the different parts of the seed is an innate property of corn that is determined by the genetics of the plant. Aside from genetics, the environment also plays a role in the chemical composition of seeds. Environmental factors that influence the chemistry of seeds include water availability, temperature, soil fertility, and even cultural practices. In the succeeding slides, we will look at how each of these environmental factors affect the accumulation of stored reserves in seeds. This slide looks at the effects of water availability on the mineral content of cereal grains. Water is a universal solvent that plays an important role in plant growth and development. In the study that generated this data, the authors looked at the effects of increasing irrigation on the nitrogen, phosphorus, potassium, calcium, and magnesium contents in the grains of wheat, barley, and oats grown in Utah. The negative sign before the values that you see here indicates a decrease, whereas the positive sign before the values indicates an increase in the mineral content. Now, from this data, we can clearly see that the nitrogen content decreased with increasing irrigation rates during seed development, despite increases in phosphorus, potassium, calcium, and magnesium across the three cereal crops. It is unclear whether the primary effects of excess moisture is on mineral absorption by the roots or on the rate of grain filling with carbohydrates. Further studies are necessary to understand the molecular basis of these responses to water availability. Aside from water availability, temperature is another key factor that affects stored reserve accumulation in seeds. This slide illustrates the effects of increasing day temperature during pod filling on the oil content of soybeans. In the x-axis, we have day temperature in Fahrenheit, and in the y-axis, we have oil content. From the line graph, we can clearly see that oil content increased from approximately 19.5% in plants that matured at 75 degrees Fahrenheit to 22.3% in plants that matured at around 85 degrees Fahrenheit. Separate studies show that soybeans planted early in the season so that they mature under warmer temperatures also recorded higher oil content. So if you are a soybean farmer wanting to improve oil content in your crop, you will have to time your planting such that your soybeans can mature when the temperature is around 85 degrees Fahrenheit. This slide illustrates another example of how temperature affects seed composition, this time in rice. We have here the rice cultivars Kinandang Patong, IR 63007, and Azucena. Kinandang Patong is a landrace that has been cultivated in upland areas in the Philippines. IR 63007 and Azucena are genotypes grown for their tolerance to drought. In tropical countries like the Philippines, rice is grown twice a year. The temperature in the Philippines usually ranges from 70 to 96 degrees Fahrenheit, depending on the month of the year and time of day. For rice to produce good quality grains, it needs a night temperature that is relatively cooler than day temperature. But in recent years, night temperatures have been gradually increasing. This gradual warming of night temperatures in the Philippines has been causing the chalky appearance of the grains, as you can see in this panel here. So in this picture, we can see the chalky grains of Kinandang Patong. Over here, we have the chalky grains of IR 63007, and over here, we have the chalky grains of Azucena. Nighttime temperature of 89 degrees Fahrenheit or higher accelerates seed development and increases protein accumulation in the grains, resulting in their chalky appearance. Soil fertility is another environmental factor affecting the chemical composition of seeds. From previous lessons, recall that nitrogen, phosphorus, and potassium are considered major elements that are absolutely necessary for plant growth and development. They cannot be substituted with any other elements, and in their absence, the plant will not be able to complete its life cycle. In this slide, we can see the effects of different rates of nitrogen, phosphorus, and potassium on the chemical composition of pumpkin seeds, particularly on the protein, fat, ash, crude fiber, and carbohydrate contents. As you can see, application of 0, 50, and 100 kg per hectare of nitrogen, phosphorus, and potassium does not have any significant effects on the chemical composition of pumpkin seeds. But when the rates of these key elements were further increased up to 250 kilograms per hectare, then we start to see a significant decrease in the contents of protein, fat, ash, and crude fiber. The carbohydrate content, however, started increasing. Lastly, we have cultural practices. The way we manage our crops has a direct effect in the chemistry of our produce. In this particular slide, we will see how various weed control treatments affect the protein, oil, antioxidant, and phenolic contents of soybean seeds. The weed control treatments include the use of different herbicides, including oxadiargyl, butyrylene, metribuzin, and a combination of bendazone plus clitodium. Manual hand weeding is also included as a treatment, and then of course we have unweeded plots as control. From the results, we can see that hand hoeing twice in the season resulted in higher contents of protein, oil, antioxidants, and phenolic compounds in soybean seeds, and this is compared to the herbicide treatments. The application of different herbicides increased the composition of the above-mentioned chemical compounds, but at a slightly lower level compared to hand hoeing. As expected, soybean fields or plots that were left unweeded produced seeds with the lowest contents of protein, oil, antioxidant, and phenolic compounds. In summary, seed reserves are stored in the form of carbohydrates, proteins, lipids, and minerals. Genetic and environmental factors affect the overall chemical composition of seeds. The natural variation that is commonly observed in the chemical composition of seeds of different species or seed parts are due to the inherent genetic properties of the mother plant producing the seed. Aside from genetics, the environment can also regulate the chemical composition of seeds. Some of the environmental factors that can directly affect seed chemical composition are water availability, soil fertility, temperature, and cultural practices.